Ladies and gentlemen, please welcome NFPA Vice President of Research, Kathleen Amond.
Morning, ladies and gentlemen. Thank you for being here. I'm pleased to give the introductory remarks. And I want you to know that in keeping with our focus on improving knowledge and information sharing throughout the NFPA community, our featured presenter is going to tell us about what he's doing to help accomplish this objective. Bart van Leeuwen is owner of NetAge, a web-based service company that helps fire departments assess fire risks based on open data, share resources, and champion fire safety education. He's also a senior career firefighter at the Amsterdam Fire Department in the Netherlands. He's an outside-the-box thinker and a popular speaker who shares NFPA's belief that data is not used to its full potential today. We hope you enjoy Bart's presentation and keep in mind his observation that the challenge is to unlock data by creating both human and technical connections in organizations so that we can all benefit from its potential. Please welcome Bart.
Good morning. First of all, I'd like to thank the NFPA for giving me the opportunity to talk to you guys out here today. My name is Bart van Leeuwen, and since I talk about data and digital, I obviously have a Twitter account, so you can reach me on this. I run a company, NetAge. I'm here on behalf of NetAge. We have been around for 20 years. We do a lot of data integration, and since about 13 years, we do a lot for fire departments. Since I'm talking to an organization who does standards, I'd like to mention that my company is also a member of the W3C. The W3C is to the web what the NFPA is to the fire service. The W3C creates standards for the web. I'll get to that a bit later. But I'm also a firefighter. I'm here on behalf of NetAge, but I take all my experience as a senior firefighter at the city of Amsterdam with me. You can see me on the lower right corner in this picture. And for the fire people in here, we do interior tech, but if I would have used a picture of that, you would not have seen me in it. These things come together to my fear. I'm afraid that something will happen to me or either one of my colleagues, and in the end, we will find out that we had the data to prevent this accident from happening. And while I've been giving these talks at several occasions, unfortunately, I've heard several cases where firefighters were sent into places and later on they figured out they had no business being there. But they didn't know that because they didn't have access to the data. And I've been pursuing this for quite a bit. This is a picture of the first prototype of my application I created at the fire station in Amsterdam where I used to work. And as you can see on the date, mind you, it's a European date, it's the 5th of December, 2009. So I'm on this for almost 7 years, actually a bit more because this is the first prototype that worked. So what I'm going to do today is I'm going to take you on my journey where I got the realizations of what I needed to change, and then I'm going to give some insights on how I think that we should treat this problem. First of all, if I talk about the fire engines we use in Amsterdam, I know that I talk to a different audience here. So on the left side, you see what we call in the Netherlands a ladder. It's an aerial on a platform with a platform on top, and it's a ladder. It's no more than that. I used to serve for 9 years as a lieutenant on one of these, and I was also the training officer for one of these. On the right side, you see a fire engine, as we call it in Amsterdam. It's a 6-man unit where we basically do everything, from extrication for car accidents to fighting fires to being the Department of Help. This is a standard combination on most of the firehouses in Amsterdam. This is me on one of my more heroic moments in my career. You can see me with the ladder saving a wounded seagull from the ice of a frozen canal in Amsterdam. And the dangerous part of this part of the job is my colleagues in the back trying to hit me with snowballs. This picture I showed before, I'm waiting here for my lineman who is in the middle of the picture to sort of, like you say in the US, hit it hard from the yard, push back the flames. We went inside. We were able to save a father and his 3-year-old girl from the back of the house. To us, this is standard. Obviously, to the persons who this happens to, it's a nightmare. It's your biggest nightmare if your house is on fire. We just do this routinely, not on a day-to-day basis, but pretty often. Obviously, we have the larger fires as well. This is a typical canal fire in the city of Amsterdam. If you look closely at the picture, you see the beautiful lanterns. And if you look a bit more closely in the background, you see there's quite a bit of equipment deployed there. Ladders, you see various hose lines. It was the facade of a 400-year-old building which was on fire here. And if we turn around the corner and see this, we are also like, whoa, that's like pretty serious. So if we go to an incident like that, if we have the 4 minutes before we arrive, what is going through our head? What are the things we think about? It's a lot. And as you can see, it's not really coordinated yet. We get a lot of information from different sources, and that is one of the problems we're facing. This is the high-tech information environment we have to work in. That's the front seat of either an engine or a ladder in Amsterdam. You see a tablet computer. If you look on the left side, you see a large set of books. You see touch screens. You see portable radios. You see mobile phones. And as you can see from the highlights of the pictures, it's not really uniform in interface. So as a lieutenant on an engine or a ladder, you have to go through all the information yourself and look at the displays and then look it up in the books. And that's where one of my problems starts. One of the things I started to notice is that a lot of these things give answers to questions we didn't ask. Navigation systems. It's great, everybody thinks, for the fire department. But as a firefighter, as an engineer, you need to know where you need to go. And this system just tells me, turn left after 30 meters. It's about 100 foot. If I'm not able to go left because the truck is unloading, it's a traffic jam, there's a market or whatever, the road is blocked, I have to make a decision, but this system doesn't tell me any of the options. And we just cannot sit and wait there what this system expects because the fire department cannot use the excuse, we're late because the traffic was busy. That doesn't really work, does it? If you would go straight, the system might tell you to turn around and take a left and you're stuck at the same point. What you actually want is to know the engineer, his endpoint, where does he need to go, and show that on a map. If we go through pre-planning, this is a standard template for pre-planning in Amsterdam. It's all in Dutch, so I didn't bother to blow it up that you could read it. It's 1 out of 5 pages for the Anne Frank house. 5 pages filled with tons of information. Mind you that getting from the fire station, which serves the Anne Frank house, to the Anne Frank house, the average arrival time is 59 seconds. I don't know if there's any firefighters in the audience, but getting all your gear on in 59 seconds is a task by itself, let alone reading through 5 pages. And if we look carefully at the upper right corner, which says these are the biggest dangers, again, it's all in Dutch, we start to realize it actually points to another piece of information, which is a standard operational procedure for a complex building. So in this 59 seconds, I have to put on my code, read 5 pages, and grab another book and read another page. All this information, all this data is not really connected. And if you start looking at the connected data around you, you start to see interesting things. You see them in cities worldwide. Indicators how much spaces are free inside park houses, which is brilliant if you need a parking spot. But if you go there as a fire engine, because there is a fire alarm there, this is not really useful, because you have no idea how big the parking house is. Is it 400 cars? Is it 350? If it's 350, there's only 8 cars parked. It's not really that interesting. If it's almost 1,000 cars, then it's almost packed. But since this information is shown digitally, the data is available, why don't we get this calculation done for us? Why do we have to do it manually? And we were faced with reality. Most of the times when we go to places, and I've talked to several firefighters who came by our booth this week, everything is fine unless you go to an incident and then you see how on earth did people get into this trouble. The biggest chemical fire in the history of the Netherlands. Chemiepak, it's somewhere in early 2012. As you can see, it's gotten pretty out of hand. The first arriving officer in a movie they made about this incident said, we knew about this plant, we had pre-plans, we did trainings with them, we did regular checks here. But when we arrived and looked what was going on, we know that everything we planned could go directly in the garbage bin. It was completely useless, because what we saw was something we've never expected to happen. The tricky part in this picture is this yellow container, which you can see in the middle. It's completely filled with acetone. There was no license for the acetone to be there, but it was just there. The fire department had no other option to deal with it. And for the people who know a bit about acetone, this makes you very scared if you see it in this environment. So they had to weigh their options. Do we gonna put out the fire with foam, but not cooling down the acetone, or will we cool the acetone, but then putting water on a chemical fire, which by definition is a very bad thing to do. In the end, they decided to cool the acetone because they were afraid that it might explode and then spreading the fire in a huge circle around the incident itself. Putting water on the acetone or on the fire made sure that the fire spread within the premises of the company and it burned down completely. But they were able to tackle the incident in the end. It burned for a couple of days. The fun part in this picture is the tagline in Dutch of the company, if you can see on the wall. It says, "We know how to deal with your chemicals." They're bankrupt now, but you figured that out. So if we talk about pre-plans, if we talk about plans and then figure out in the incidents we don't need them or we can't use them, should we create more extreme pre-plans? Should we do weird stuff? Well, probably not. Or should we? What you see is a family car about 30 feet high in a church roof. And now comes the question, what kind of incident is this? Is this an extrication? Is this an elevated rescue? Is it a building collapse? Well, actually, it's all in one. And as fire department, you just go there and you solve it. It's not something that you say, well, we haven't trained this before. I'm not going to do it. We will always solve it. But we have problems in identifying incidents like this because the way we use information basically says an incident is of one certain type. If you go browse the internet, you're going to find tons and tons of pictures. What is this? Is this a plane crash or a train crash? In the Dutch classification system, we have a classification for disrupted railroad traffic. And we have a classification for a plane crash. You tell me. Probably it's undecided. When I started going over all the weird incidents I've been through, I was reminded by a book, The Black Swan. The theory of the Black Swan theory, which basically mentions the impact of the highly improbable. It has nothing to do with the movie on the ballet dancer, by the way. This book is written in the aftermath of the economic crisis, where everybody said, okay, we should have seen that coming, but for some reason, nobody did. And the author of this book, Nassim Taleb, created a whole array of these incidents that everybody was, we should have seen that coming, but up front, nobody did it. And they were very disruptive. The invention of the wheel, World War II, Fukushima is a very famous example. And I started to realize that a lot of the incidents I've been through as a firefighter are tiny black swans. Not at Fukushima scale, but still incidents that you think, how on earth did the people get themselves in this situation? So where does this black swan thing come from? When they started categorizing birds somewhere in Europe in the late 1700s, they picked a bird and then described it. And then they had a white bird. A big white bird was a swan. A swan was a big white bird. Black swans only existed in New Zealand and Australia. So when the people started sailing the world and found a black swan, they were pretty sure it wasn't a swan, because swans were white. They were so sure that black swans didn't exist that Old English has an expression, something will happen sooner than you'll find the black swan. So they took the poor animal apart and then they figured out, well, it's probably a swan. And later on they realized that a black swan is not that difficult to create. It's a very interesting read, this book, by the way. So if we want to be better informed in incidents like this, if we want to be better, and trust me, you cannot predict black swans. Don't let everybody tell you that you can't predict them. But you can signal that something strange is going on. So what we actually want in this 4 minutes that we drive there, that the information is way more structured and we can actually put up a red flag. You're going somewhere which might not be the standard, which might not be something you have encountered before. That is the thing I'm trying to persuade. So how does it come with all this data? And why is that so important nowadays? We live in an information society. I bet, and from this stage I can't do sort of a raise of hands, but I bet that the larger part of the audience booked this trip here online, booked everything online. We do everything online. Maybe people are tweeting about my talk right now online. We live in an information society. And we start to create enormous amounts of data. And that is where my fear comes from. There might be some information which might be to save my life. There is this metric on data growth, on the amount of data we collect as a society. Every 2 years, we collect twice the amount of data as we have collected before. So some people with a mathematical background might say, okay, that sounds exponential, and it is. I created a simple sample on standards. So what if you are an author of standards? And in your first year, and it's too small to read probably for most people, in your first year you're going to create 5 standards. After 2 years, in this phase, you would have created 15 standards, and then in 10 years you have 1,215 standards. In your 30-year career, you created more standards than the Library of Congress has books. I visited the NFPA in January, and I've seen their library. It wouldn't fit. So if we graph this, it looks like this. And suddenly there is a steep spark of the amount of information. And the little green arrow is at the 20-year point. You should look back at the history of the web, the infrastructure that allows us to gather and share information. It's about 20 years old. And we are already talking now about big data problems. We're not even there yet. So let me give you an example of what big data means. A couple of weeks ago, I had the pleasure of flying a new Boeing Dreamliner of KLM, and it's a very advanced plane. It's completely filled with sensors. So many sensors that one flight of a Boeing Dreamliner generates 0.5 terabyte of data. That's a 5 with 11 zeros. To get the data out, you would need 800 compact disks, and for the people who have never used them, probably 32 16 gigabyte iPhones to store all this information. But that's one flight. They have a great website where you can see all the movement of all the Dreamliners worldwide. I scanned it for a bit, like 300 flights a day. So you have 150 terabytes of data, which is a 15, which is a countless amount of zeros. 250,000 compact disks of data is being produced by the worldwide fleet of Dreamliners. Well, if you go for 1 year, you talk about 100,000 flights, 50 petabytes. It's incomprehensible amount of data, and almost 100,000 CDs. And they still need to process it. And why do they collect all this data? They change from saying, okay, every plane needs to come in every month, to the plane telling them by data, I need to come in because some of my sensors tell me something that something is wrong. Planes can keep flying longer, and problems are detected earlier because the sensor data shows something out of the unusual. And this is just one type of airplane, which is very recent, but this is going to come everywhere. This is what we call big data. Big data is about volume, variety. It has sensors on fuel levels, on how many times people sat on the toilet during a flight. Seriously, it's in there. It comes in at great speed. Processing 800 CDs for just one flight is like unthinkable to do. And veracity. How trustworthy is this information? If somebody ever watched Air Crash Investigation, you'll see that sensors sometimes are wrong. So you have to go about correcting this data as well. And if you go around the world of big data, you go to the conferences of IBM and all the other big players in the big data field, you'll notice that everybody says, well, we got you covered. Treating these amounts of data, we can do that. That's not a problem. The thing is, how do we make sense out of all this? If we got these amounts of data, how do we make sense? And although I claim that the fire service is not yet doing big data, we might get there pretty soon, making sense out of everything is still very, very important. For the Dutch Fire Department, we realized this about 7 years ago as well, and we introduced this concept, the Firebrary, a fire library. It's an authoritative set of fire department terms where we have an electronic dictionary which software can use to communicate the meaning of the terminology in the data we communicate between fire departments and the service we work together with. And why is this important? Why is it important that we communicate the meaning of what we say? Because otherwise you might assume things by reading the data which are completely wrong. So this slide, I did exactly the same. I know that a lot of people in here do not have the same concept of a fire engine and a ladder. So before I began my talk, I used my private Firebrary to communicate to you guys, like, okay, this is what I mean with a ladder, and this is what I mean with an engine, so you are on the same level as me. It is that simple. Communicate what you want to say before you're actually going to exchange information. So what can we do with all this data we have up to date? And I saw a great session this morning, and there's been tons of examples around the country here as well. And for example, using data to do predictions, or I don't really like the word prediction, to picture what the risk nature of your surroundings are, of your service area are. So we did an example for the harbor of Rotterdam. These are all the neighborhoods in the greater vicinity of Rotterdam. These are all the fire-related incidents, and you can see that they're concentrated in certain spots. And if you would go and do some metrics on socioeconomic background of the people who live there, the type of buildings they live in, and there's tons and tons of data points you can add to that, you create the same picture. And funnily enough, if you overlay them, you can actually see, okay, the places where the risk is the highest, we indeed have the proper amount of incidents. Another thing what you could do is actually measure your performance of your fire department. In which of these places are we on time? And it might as well be that in the green areas you do not meet your response times. But then you can say, well, the risk is low, and if you really want us to meet those response times there, you probably have to put a fire station in every corner. And we don't have the money for that, but at least you have a picture to show stuff. These are very simple things which you can already do with the data we collected up to date. But I told you about this spark which is coming up. It's the connected world. And when I walked over the expo in the last few days, I noticed that there's tons of material out there, fire panels, smoke detectors, sprinkler pumps, sprinkler installation systems. They're all able to emit data. And that is in a more commercial setting. But we're starting to do this in our homes as well. The homes of the people we serve are getting smarter and smarter every day. Nest is one of the examples, that connected smoke detector. And if you connect this smoke detector to the web and do some cool analytics with it, you can do this. Not sure if everybody can read it, but it says, I think my Nest smoke alarm is going off. Google AdWords just pitched me a fire extinguisher and an offer for temporary housing. This is very cynical, but essentially it should be able to work. I think you earlier find it on your app that your smoke alarm is going off than with Google AdWords, but you get the point out of this. But also in firefighting, you see more and more sensors. This is a picture I took this year at the expo with FDIC, and it has an air gouge with a little display on it. And what they did, they created mesh networks inside the apparatus, the SCBAs. And you can see a couple of lines there. You see a red piece and a green piece. And this is said to be alarming as soon as some of your colleagues are more than 20 feet away from you. So you go in as a team fighting the fire, and if one of your buddies is more than 20 feet away of you, all the air gouges are going in alarm. Like, hey, somebody's too far away. And they can do all sorts of cool stuff with that. They can say, okay, we can even detect if a firefighter falls down the stairs or a floor gives in. We can give everybody an alarm. Well, that's great. And I talked to the guys there and said, how do I see it from the outside? How can an incident commander deal with that? We give him an app. Okay. A couple of years ago, Amsterdam Fire Department was commissioning new fire engines, and one of the things I said, we need open data fire engines. We need fire engines which emit all their data. Their pump performance, how much water do we put through, how much water is still in the tank, how much diesel is left. Put gas sensors around the fire engine. I want all this data. We talked to some vendors and they said, we can give you an app for that. But I want the data. I want to be able to look at the data. And why is that? Why is access to this data so important instead of an app? First of all, if we have all these cool features with an app, we end up with firefighters pulling up in front of a house and then scrolling 2 minutes on their iPads to figure out which apps they need for that fire. Luckily enough, we do not select the people to act like that. So most firefighters, luckily, will march into action right away. And it's socially not accepted. I bet people will start pulling firefighters off the truck when they start scrolling on their iPad. So what you want is this stuff to be open. And this sensor stuff is getting really interesting. This is a really small, it's a huge picture obviously, but it's like this big. Sensor tag from Texas Instruments. It's a development kit. It's not for industry use, but it allows you to play around with sensors. It's got 20 sensors in there: temperature, ambient temperature, radiant temperature, air pressure, light strength, angle of movement, speed of movement, gravity, etc., air pressure. You can hook this up to a phone or a simple computer. These things cost $35. You can hook it up to an old phone or a Raspberry Pi, also $35. And then you have a web interface where you can basically hook the values of sensors and point and click. You don't even have to do programming for this. And you can attach this stuff to, for example, the data analytics sandbox of the NFPA and do all sorts of interesting things with your sensor readings for $60. Soon enough, we will have a firefighter which is just as smart as this kid who found this cancer detection mechanism through reading Wikipedia. We need to be able to give people the access to the data we generate as a fire service to create cool new applications for that. And we shouldn't do that by just giving them apps. We should give them access to the data. But that needs some sort of infrastructure. It needs a very large infrastructure. Luckily enough, the largest infrastructure we have as a society right now is the web. Like I said before, everybody in this room, or at least a very large part, used the web to get here. So what can we do with this large infrastructure, and how resilient is it? If you look at the reports, for example, of Sandy in the New York area, people were opening up their Wi-Fi hotspots, etc., etc. So this thing is very resilient, more resilient than we like to believe. The cool thing is that this infrastructure was originally developed to transfer data as well. And the concept of using the web for data is called linked data. I can talk an hour or two about linked data, so I'm not going to bother you with the technological background of it. But somebody from the W3C created a tweet. Linked data uses the concepts and technologies of the web to describe the world. And he was so proud that it fitted in a tweet that he actually wrote that down as well. No acronyms, no tag, one tweet. So what is this, the web? This is the original design document of the web, and if you look in the upper right corner, this is written by Tim Berners-Lee in 1998. Tim Berners-Lee, the inventor of the web, the godfather of the web, basically. And he wrote this when he was a student at CERN in Switzerland. And his professor wrote on the top, vague but exciting. That's a bit more than 20 years ago. This is the original drawing of the web, and what you can see here, if you could read it, but it's going to be in my slides, you can see all sort of data points pointing at each other with meaning, and this data was connected. This data was pointing to each other with explanations, with meaning in it. So this concept of putting data on the web and then making sure that it contains its own meaning is very old. We just have not been using it wild enough. So what are the concepts and techniques of the web? Concepts of the web is a contextual linking of documents by reference. And take a Wikipedia page in mind. So you go to a city page and then you look it up and you can find the name of a famous person who was born there. And you see the link. The reference contains information. The link goes to another page and you know that you will get to this famous person because the link says it's about this famous person. And if you go to the famous person page, you'll get another document pointing to, again, other documents about the achievements of what he did, or the stupid things he did, for that matter. And the technology behind that is that there's an unlimited amount of locations where you can store information. Nobody knows where this Wikipedia document comes from if you look it up on your iPhone. Nobody knows. And you have no interest in knowing the way to get it. The web solves that for you. If you translate this to linked data, it's exactly the same. We have data pointing to other data, and the reference to this other data actually contains the information of that data. And the data you'll find back contains information about itself and points to other information, and you don't have to care where it is. The routing is taken care of. This is a very, very powerful concept. The Dutch base registry of address and buildings were supplying the fire service with maps. And all the text is too tiny to read, but we were able to overlay our internal GIS systems with the maps of where all the buildings were and what the addresses were. But still, it was just only available in GIS systems. And if you wanted to do some analytics, you had to do some complicated queries on that. Now they publish everything as linked data, and all the information you can see in the right column, or you see a right column and you cannot read it probably, but has links on meaning explaining what this text or this number actually means and what the rationale behind it is. This allows us to do some processing on it without needing experts of the cadastre, the base address registration owner, to explain it to us because they've written it down. And the great thing is that computers can actually do the calculation with it. We started doing that as well. The Fireberry, remember? It uses the same technology to explain all the terminology we use. It's the same linked data technology, the same open web technology. And the fire department in Amsterdam, where we are running a demo project and we're going to open it up, is tweeting all its incidents real time. But it uses data in its tweets. This is so real time that if I got a priority 3 message at my fire station, I can take out my phone, look up on Twitter, and before the alarm sounding is stopped, I can tell my colleagues we go there. It's absolutely real time. And at the bottom you can see a link pointing to the page describing the incident. We have a web page describing the incident, and you see the green bar in the middle, which is actually pointing to the Fireberry. So we can tell the public, well, we do not just give you the data, but we also give you the explanation of the data. You can look it up. And people who create applications can create XML or JSON representations of this data as well. We're just putting it out there for free. Because we realize if we want to do all this cool analytic stuff, we need data from others. But if we're going to demand that, why do not give the data we create away as well? One of the observations I had, and I'm not sure if he is in the audience, on the Boston keynote earlier this week, that I didn't see any fire data in this dashboard. I'm not sure it's not there, but I was surprised that he was talking at this audience and not showing fire data. And if you go around the globe, there's not too much fire departments actually emitting their data, but everybody starts to understand we need to use data. I think it's not a one-way street. We need to do it both ways. Also to give other people very interesting possibilities with our data. And I know this is a bit controversial, but the success of the web is the fact that they use open standards. Everybody's free to use the standards of W3C. You don't have to pay for them, you just can adopt them. And I think if we want to make this interchange of information between fire service and the industry more and more open and more reachable for even the smart kids creating cool applications with those sensor tags, we need to create open standards on how to interchange information with the fire service. The current standards we impose on building regulations, et cetera, we can legally do. But if you want to have information from a park house and how many cars there are parked, we do not have any legal options to say you have to supply it in a standard we created. We better can create or adhere standards which are already out there. And that's where the W3C could play a role. And I've been talking backstage to people that we might actually hook up W3C and NFPA to do something like this. The W3C is working on the data activity. It's a standard of putting data on the web. You can find some of the spots here. The data on the web best practices is just a document. If you want to publish your data, these are the best practices how to do it. And we could tell as fire service to the governments we work with, like, we would like you to use this data format or to follow these best practices. Because then it's easy for us to use it. We're not going to enforce any standard on you, just use these best practices. And the same goes for the spatial data on the web. This example I showed you earlier with the cadastre maps of all the buildings, they're using this kind of best practice as well to publish it. I'm very lucky and very proud that the spatial data on the web best practices working group is actually using a narrative of a flooding event initiated by my company to say, okay, this gives a good narrative to explain why we need these kind of standards. So it's actually got an emergency response touch to it as well. So we talked about all the cool things you could do. I saw tons of examples on the show here. But there are some other side to this, some reflections. So when I talk to fire departments and say, well, you could do all sorts of cool things with data, I very often run into the 99% correct dilemma. I had it at my own fire department as well. We cannot use this data set because it's only correct for 99%. Effectively, that means that you're going to deprive all your responding personnel in 99% of the times of quality information which could be used for their great benefit, just because this 1% is not correct. And somewhat in line with that is all these positive stories you hear. We can do great things. It's the optimism bias. We only think about the great possibilities we have if all this data is put together. We only talk about the upside. But I think that if we're going to send in people based on this data, if we're going to put lives on the line in the operations of the fire service, and we're going to send in people, we should think about the downside. What if the information we gathered, what if all the cool analytics we did create wrong information? How are we going to deal with that? That is sort of essentially where my fear is as well. And I think that the answer to this is pretty simple. We should make the people who use this data smart as well. Like with the navigation system, when we used the navigation system in the city of Amsterdam, I had a taxi driver coming to the fire department. After 2 years, he said, I knew every street in the city of Amsterdam. I've been a driver at the fire department for 2 years, and I have no clue where the streets are anymore. And you hear it a lot when people take out their mobile phones. Since I have this thing, I turn dumb. I can't remember names, I can't remember phone numbers. We do not want firefighters, fire response personnel, to just rely solely on what a screen or a contact lens or a heads-up display in their mask is giving them. We have to stay on their edge as well. So this is where the technology, where you can create great insights, but we also have to make sure that the people who use it in the end stay up to steam with what this data is giving them and keep making proper decisions if they go to these weird incidents. So I hope I inspired you a bit with some of the ideas I have on how we can use this data better and what the important thing is and what the task is ahead for us to integrate data in the fire service better. So how's my fear? When I started this 8 years ago, I was like, okay, nobody is actually understanding what I'm talking about. Initially, I was afraid to be booed away by the central command of the city of Amsterdam, and to my utter surprise, they said, don't be afraid. We send you guys to places where you actually should not go, but we have no means of telling you. Obviously, if you're not alone, there's quite a bit of people listening here, and I got the opportunity to talk about this, your fears goes away. And initiatives like the Analytics Sandbox and using data for the fire service better is definitely helping. But I'm still on the edge of being afraid because I still see things happening which are not good. So what were my goals? I wanted to get it out there. Well, I think I've probably succeeded with that here. And I still would like to have opportunities to discuss also with firefighters. I've been teaching at FDIC this year what it means to all this information to a situational awareness. How do you prevent firefighters from dumping down of all the information they get through their systems? So if you have any opportunity and you have any idea where I should be able to present this, then just let me know. Since the room is so big, we're not doing any questions, but I know there is one question. How did he get up there? This is in the eastern part of Germany. They don't have speed limits in Germany. This guy was doing probably 120 miles an hour, missed the off-ramp, launched himself about 50 meters, that's about 150 feet through the air, and got himself stuck up in a church roof. It took the fire department like a good 2 hours to figure out, like, how do we get this guy out of here? They managed in the end, and I have no idea if he's still alive if you got a driving style like that. Thank you.